Welcome to my YouTube channel. Today we'll be solving more advanced question on resistance. Now, we have a question on the board that says, what is the current delivered by the battery? Now, here we have a circuit that has three resistors. Two are connected in parallel and one is in series. Now, before we can solve this question, if you have not watched my recent video on resistors, please do well to subscribe to my YouTube channel. Click the link below, subscribe and watch the video to get a basic knowledge on the calculation of resistance. So we have to look for the current delivered by this particular circuit. We have a battery that has 18 volts and here we have resistors. So here we have two parallel connection and one series connection. So first of all, we must break them down. We must look for the equivalent resistance before we can solve for the current. Now, before you can solve this question, remember you must have knowledge on Ohm's law. Ohm's law. The Ohm's law states that the current flowing through a conductor, that is a wire, is directly proportional to the potential difference connected across its end. What this means is that electric current, that is I, is directly proportional to the what? To the volt. So if the electric current is directly proportional to the volt, it also means that the volt is also directly proportional to the what? To the electric current. So we have V is equals to IR. Remember, the R is the constant called the resistance. So here is the formula for the volt. Now, to make electric current the subject formula, you have to divide through by what? By the coefficient of I, which is the R. So divide both sides by R. We have I is equal to V over R. Now keep this formula. Keep it. Keep this formula. We are going to need it. We are going to need this formula later. So keep it aside. Now, let's start solving. But first, you are going to resolve this parallel connection of resistors before we can solve for the current. Now, remember in my last video, I taught you how to how you can actually resolve, that is defined to find the equivalent resistance of resistors, either connected in series or in parallel. Now, for the parallel, you have 1 over R is equals to 1 over R1 plus 1 over R2. So if we use this formula, we are going to have 1 over R is equals to 1 over 3, which is the R1, plus 1 over 6, which is the R2. So you may not need to look for LCM. Now let me teach you how you can solve it very quick. 6 times 1 is 6. 6 times 3 is 18. Plus we have 3 times 3. 3 times 1 is 3. And 3 times 6 is 18. So since we have two the same denominator, kindly pick one of them. So we have 6 plus 3. That's 9 over 18. 9 over 18. So 9 over 18. Remember, 1 over R is equals to 9 over 18. So you can cross multiply to give us R. 9R is equals to 18, because 18 times 1 is 18. So divide both sides by 9. 9 cancel 9. We have R is equals to 2 ohms. So R is equals to 2 ohms. That is the resistors in series, 2 ohms. Now, these 2 ohms plus the 4 ohm in series. This is for the parallel. Sorry, that was an error. This for the parallel, the equivalent resistance for the parallel connection. We have 2 ohms. So these 2 ohms plus these 4 ohms now in series is going to give us 6. So that means R, the resistance, is equals to what? 6. That is the equivalent, the total resistance. Resistance in this circuit is 6 ohms. So using this formula, now let us substitute using this particular formula. We have a volt as 18. Then we are looking for the electric current. We are looking for electric current, and our resistance is 6 ohms. 6 ohm. 18 volts, 6 ohms, and then we are looking for the what? The electric current. That is the current delivered in the circuit. So using this formula, we have I is equal to our volt 18 over our resistance 6. So divide, I'm going to get 3 we're going to get 3 amperes. 3 amperes. So the electric current delivered by this particular battery is 3 amperes. So our option, the best option here, is no other option than